present. And then camera. All right, can everybody see in here?
Yep.
Yep, okay. All right, so this is a review of factoring from grade 10. All right, so we're reviewing how to fully factor a polynomial expression. Please, I can't see if your hand's up or whatever, so just interrupt if you're having trouble understanding. The grade 10s, you're probably fine, or it's just going to be recall for you. Some of the grade 11s, depending on whether you took math first or second semester, some of it you may not have seen because you missed it because of distance learning. So please take the time to stop and say, I'm not sure what you did there. Okay, so factoring a number is to write it as a product of its prime factors. So way back in grade, I don't know, 5 or 6, you would write 30 as 2 times 3 times 5, okay? Which are, other than times 1, it's smallest factors that go evenly into it. Factoring an algebraic expression is to write it as a product of its prime algebraic factors. So for instance, x squared minus 16 is a difference, but x plus 4 times x minus 4 is a product because we're multiplying. These brackets mean multiplying 2 factors together. So when you factor, you find an equivalent representation. So these two statements, x squared minus 16 and x plus 4 times x minus 4, mean exactly the same thing. They're just written differently. Okay, and we're going to be factoring for the purpose of simplifying rational functions, which we're going to do in our second lesson today. So we're just going to sharpen or remember our skills on the different types of factoring this morning. Okay, so factor each algebraic expression by common factoring. So the first type of factoring everybody learns, and it's at the top of the flow chart. You always check for common factors first. So what is a common factor, first of all? So if you're looking for the common factor, you would be looking for the biggest number that divides evenly into each term. So that's the number part. And then for the variables, if the variable is in all terms, choose the smallest exponent. So that's how you determine what the greatest common factor is. So to figure out the number part of the greatest common factor, it's the biggest number that divides evenly into all the terms. And to get the variable part, you can only choose the variable if it's in all of the terms. And if it is in all of the terms, you choose the smallest exponent on that variable. Okay, so that's how you get the greatest common factor. And then we'll see how you use it to common factor. So that's what a common factor is. So you're looking for what's in common with all of the terms. That's why it's called common factoring. So factor each algebraic expression by common factoring. So 5x plus 20. So our two terms are 5x and 20. And first we want to look for the biggest number that divides evenly into 5 and 20. So often you'll just check, does 5 go into 20 evenly? And it does. So we know 5 goes into itself. So 5 is going to be the number part of our greatest common factor. And then we would check and see, is there an x in both terms? No. So in this case, 5 is just our greatest common factor. So we're going to write 5x plus 20 as the product of 5 and another factor. And to determine that other factor, what you want to do is mentally divide each term by 5. So I'm thinking to myself, I'm not necessarily writing it here, but I'm showing you what I'm thinking. I'm thinking 5x divided by 5 is x. And then positive 20 divided by 5 is positive 4. So I can rewrite 5x plus 20 as 5 times x plus 4. And again, if you wanted to check if your factoring was correct, you could distribute, expand by distributing, and you should be able to get back with what you start with. 5 times x is 5x. 5 times positive 4 is positive 20. So that is your common factoring of 5x plus 20. So same idea for B. So there's two terms here again, 3x squared and negative 15x. So check and see if 3 goes into 15. That's usually the easiest thing to check, and it does. So 3 is going to be the numeric part of my greatest common factor. And then in this case, there is an x in both terms. So we want to choose the smallest exponent on x, which would just be a 1, which you don't see there. Okay, so 3x is my greatest common factor. And then I'm going to mentally divide each term by 3x. Okay, and if you're not at the point of being able to mentally divide them, I'm just going to do some on paper here for you. So 3x squared divided by 3x is, well, 3 divided by 3 is 1. X squared divided by x. You may need to remember the exponent laws. When you divide powers with the same base, you keep the base and subtract the exponents, giving you just x to the 1 or x. Or you may see it as 3x squared divided by 3x. The 3's divide out. You have 2 x's multiplying together on the top, 1 on the bottom. So 1 on the bottom goes with 1 on the top, and you're left with x. So 3x squared divided by 3 is x. And then negative 15x divided by 3x. Negative 15 divided by 3 is negative 5. X divided by x is 1. So minus 5. And again, if you want to, you don't have to, you can check your answer by expanding. 3x times x is 3x squared. 3x times negative 5 is negative 15x. And so this is correct. Okay, so we're getting a little bit harder. We've got 12x squared y and 20xy squared. So I'd first check, does 12 go into 20? No, not evenly. So I want to find a smaller number that goes into both of them, but I want the biggest smaller number. For instance, 2 goes into both of them, but it's not my greatest common factor because 4 also goes into both of them. Okay, and it turns out 4 is the largest number that divides evenly into 12 and 20. And then in each term, there's also an x, and I choose the x with the smallest exponent. And in both terms, there's also a y, and the smallest exponent on y is also a 1. So the greatest common factor is 4xy. And then again, you're mentally dividing. 12x squared y divided by 4xy is 3x. And negative 20xy squared divided by the greatest common factor, 4xy, is negative 5y. Okay, and again, you could check. 4xy times 3x minus 5y. 4 times 3 is 12. x times x is x squared times y. And then 4 times negative 5 is negative 20. X, y times y is y squared. So that's correct. All right, and D, negative 3x plus 6. So kind of a little rule I have is whenever there's a leading negative, I always make negative part of my greatest common factor. Okay, even if it's just negative 1. But in our case, 3 goes into 6, so negative 3 is going to be the numeric part of my greatest common factor. And then it will actually just be my greatest common factor because there's not an x in both terms. So negative 3x divided by negative 3 is x. Don't write a sign down till you know. Positive 6 divided by negative 3 is negative 2. So that would be common factored. In E, there's a 1 in front of both terms, so I wouldn't write the 1 down if it's the greatest common factor. Then there's an m in both of them, so the smaller exponent on m is just a 1, plain m. And there's also an n in both of them. And again, you're thinking m squared n divided by mn. Back to like grade 9 exponent laws. That's going to be m to the 1, and then the n's cancel out because they're the same. And then negative mn squared divided by mn is going to be negative n. So there is your common factored expression. For F, there's 3 terms this time. There's a leading negative, so that's going to be part of my greatest common factor. 7 goes into 21. And then I would check and see, does it also go into 35? Yes. So negative 7 is the numeric part of my greatest common factor. There's a k in all of them. And then the smallest exponent is k cubed. So I'm going to divide each term, so negative 7k to the 4th divided by negative 7k cubed is just k to the power of 1, or just k. And then 21, positive 21k cubed divided by negative 7k cubed is just 21 divided by negative 7 is negative 3. And the k cubes cancel out. And then negative 35k to the 6th divided by negative 7k cubed is going to be positive 5k to the 3rd, 6 minus 3. So plus 5k cubed. All right, so that's a review of common factoring from grade 10. A simple trinomial is the product of 2 binomials. So if you remember from grade 10 is where you learned how to expand these using, I call it FOIL, which stands for firsts, outsides, insides, and lasts. So you multiply the 2 firsts together, the 2 outsides together, the 2 insides together, and the 2 lasts together. It's also we call it the double distributive property. Each term in the first bracket is multiplied by each term in the second bracket. So x times x is x squared. X times positive 3 is positive 3x. Positive 5 times x is positive 5x. And positive 5 times 3 is positive 15. And then what usually happens is the middle terms are like terms and they can be combined. And you get what's called a simple trinomial when you multiply those 2 binomials together in this case. So going from this to this is called factoring, and that's what we're going to do now, factoring a simple trinomial. We turn the page over, which is another skill you learned in grade 10. So factor each simple trinomial using product sum. Okay, so what does this product sum mean? So, and it also tells you that there's one step. And if you look on your factoring flowchart, once you've checked for common factors first, you count the number of terms in the brackets, or if there's no common factor, just count the number of terms. If there's 3 terms, which there is, if it's a simple trinomial, again, which it is, then it's just one step. So how do we tell a simple trinomial? Well, it's got this format where you've got x squared, then plus some number x, and then plus a plain number, and the number in front of x squared is a 1. Okay, that's a simple trinomial. And they always factor to give you 2 binomials. And then if we start with x squared, to get that x squared, there's going to be an x at the start of each binomial. And then to figure out the numbers that finish the binomial, you need 2 numbers that multiply to 15. So that's where the product part comes in. But they also have to add to, in this case, positive 8. So we need 2 numbers that multiply to positive 15 and add to positive 8. So if you're the times tables champion of your class, you probably just already know what they are and you write them in. If not, you're going to do kind of like an organized list here. So start with your 1 times table, 1 and 15, 1 times 15 multiplies to 15, but 1 plus 15 does not add to 8, so that's not the pair, and only 1 pair will ever work. 2 doesn't go into 15 evenly, 3 does, so 3 times 5 multiplies to 15, 3 plus 5 adds to 8, so it must be positive 3 and positive 5. And you could also have x plus 5 times x plus 3. Doesn't matter. Okay, is that the one we did over here? Yes, it is. So if you turn your page back over, you can see that what happened when we multiplied x plus 5 by x plus 3, we got x squared plus 8x plus 15. Okay, so there's our check already done for us. So that's how you factor a simple trinomial. It's easy when they're all positive signs. You have to do a little bit more thinking when there's negative signs involved. So again, you recognize it's a simple trinomial, so you know it's going to be one step. So you're going to already write out your 2 binomials with an x at the start of each bracket because it's x squared. X times x when you're expanding is what would give you the x squared. Now you're multiplying to give yourself negative 24. So when you multiply 2 numbers together and you get a negative, one of them has to be positive and one of them has to be negative. Okay? So keep that in mind. So when you add your sum part, you add 2 numbers together. And you know one of them is positive and one of them is negative, but you end up with a negative answer. The bigger number of the 2 is going to have to be negative. The negatives are going to have to outweigh the positives. So when you're writing your organized list, for instance, the 1 times table, you're going to use 1 and negative 24 because the bigger of the 2 numbers has to be the negative one. And then you try that out. Is 1 plus negative 24 negative 2? No. So then I know 2 times 12 is 24, so I'm going to do 2 and negative 12. That adds up to negative 10, so that's not the numbers. And then I know 3 and 8 multiply to 24, so 3 and negative 8 adds up to negative 5. They're not the numbers. 4 and 6, 4 and negative 6. 4 and negative 6 does add up to negative 2, so they must be the numbers. So x plus 4 times x minus 6. I've got my bracket a little far over here. I'll just move it. So if I factor x squared minus 2x minus 24, I should get x plus 4 times x minus 6. And if you were to expand that out, doing this, you would end up getting x squared minus 2x minus 24 back. All right, C, also a simple trinomial, even though it's not an x, it's an m, that's okay. Still got that same format, a variable squared plus, in this case, a 1 times the variable minus a plain number. So we're going to do our two binomials, an m at the start of each instead of an x. And then our two numbers have to multiply to negative 20 and add to positive 1. So again, I'm multiplying to a negative, so one number has to be positive and one negative. But this time I'm adding up to a positive, so the positives have to outweigh the negatives. So again, when I'm writing out my list, I'm going to always make sure the bigger number is positive this time. So for my 1 times table, I would do 1 and 20, but make the 1 negative and the 20 positive. And that adds up to 19, so they're not the numbers. 2 and 10, so I'd make it negative 2 and positive 10. That adds up to 8, they're not the numbers. 3 doesn't go evenly into 20. 4 and 5, so negative 4 and positive 5. That does add up to positive 1, so they must be the numbers. M minus 4 times m plus 5. And if I wasn't sure, I could always expand, okay, using FOIL on a separate piece of paper and do a check, and I should end up with m squared plus 1m minus 20. All right, D. It looks complicated because it's got this a, b, and b squared, but because it's still got the pattern, like if I was going to put my finger over the b and the b squared, it would follow the simple trinomial pattern because there's a 1 out front of the a squared. There's a simple fix to just factor this as a simple trinomial. And that's that you start each factor with an a, but to end up with b squared at the end, you're going to end each factor with a b. And we'll check this one on paper to convince you. And then, so we want to look at the numbers positive 16. So we want to multiply to get a positive, but we want to add to get a negative. So if you're multiplying two numbers and getting a positive, but adding those same two numbers and getting a negative, the only way that's possible is if both numbers are negative, because a negative times a negative is a positive. So keep that in mind. So again, start with your 1 times table. Negative 1 and negative 16 does not add up to negative 10. Negative 2 and negative 8 does. So it's a minus 2b and a minus 8b. Okay, and then I do want to check that for you. So we'll do a little check here, because this is kind of a little bit harder one that you don't always recognize as a simple trinomial. So again, to check it, you're going to do the expanding using FOIL. So a times a is a squared. A times negative 8b. So that's going to be negative 8ab. And then negative 2b times a is negative 2ab. And then negative 2b times negative 8b, so those are our last, is positive 16, and b times b is b squared. And you can see the middle terms can be collected. So negative 8ab minus 2ab is negative 10ab. And that's what we started with. So it is correct. It's a simple trinomial, even though it looks more complicated. So using that, we should be able to do E, same idea. Okay, so we're going to have an x at the beginning of each factor, and then we need a y at the end of each factor because we end with the y squared and we have xy in the middle. And then we need two numbers that multiply to negative 24 and add to -2. So 1 positive, 1 negative, bigger 1 negative. So 1 and -24, nope. 2 and -12, no. 3 and -8, no. 4 and -6, yes. So x plus 4y, x minus 6y. And you can see it's very similar to the question that's right above it, only we added the y and the y squared. Same two numbers though, which also shows you how it's a simple trinomial. And then f, x at the start of each. You want two numbers that multiply to -40 this time and add to +3. So multiplying to a negative, one's positive, one's negative. Add to 3, the bigger one is positive. So -1 and +40, nope. -2 and +20, no. 3 doesn't go in, 4 does. -4 and +10, nope. -5 and +8 does add up to +3. So it's x minus 5 times x plus 8. Okay. All right, factor each complex trinomial using the method of decomposition. So a complex trinomial is different from a simple trinomial because the number in front of x squared is not a 1, it's a 3. And you have to use this decomposition method, which involves 3 steps in order to factor it. So the first step is to multiply the first term and the last term. So 3x squared times 4 is actually 12x squared, and we write it off to the side. And then we want to come up with 2 terms, not numbers, but terms, that multiply to 12x squared, but add up to 13x. So we can start off again with our 1 times table, so 1x and 12x. It does multiply to 12x squared, and it also does add to 13x. So those are the, not numbers, but terms we're going to use. And what are we going to use them for? We're going to use them to decompose 13x. So this is what our thinking is. We write down the 3x squared, and then we ask ourselves from a common factoring point of view, what has more in common with 3x squared, 1x or 12x? And I would say because 3 goes into 12, 12x has more in common. So I'm going to write plus 12x next. And then the one I didn't use, plus 1x. And then I'm going to end with plus 4. So in this first step of decomposition, all I did was rewrite plus 13x into plus 12x plus 1x. All I did was decompose 13x into the sum of 12x and 1x. So these two lines are exactly equivalent. I've still got the 3x squared. I've broken the 13x into positive 12x plus 1x, and then I still have the plus 4. Okay, so that's my first step. The decomposition step really is that first step there. The second step is to what we start factoring by grouping. So we just look at what's at the first 2 terms first, and we say what's in common by a common factoring perspective between just 3x squared and 12x. Well, 3 goes into 12, so 3 is in common. And there's an x squared in the first term and an x in the second, so x is common. And then I common factor. So 3x squared divided by 3x is x. Positive 12x divided by 3x is positive 4. So I just common factored the first 2 terms. Now, whatever sign comes next, whether it's positive or negative, goes next. So in this case, it's positive. It goes next. And now I'm looking at what's in common with the last 2 terms, positive 1x and 4. And the only thing in common is 1. And then you still common factor even though 1's the only thing in common. 1x divided by 1 is x. Positive 4 divided by positive 1 is positive 4. And if you do everything right when you're factoring a complex trinomial, what happens is these binomials end up being exactly the same, x plus 4. And we call them a common binomial. So that common binomial is a common factor. So we've got these two big chunks, and both of these big chunks here have the binomial x plus 4 in common. Okay? And I always say the leftovers, 3x plus 1, form the other factor, and that's how you fully factored it. And if you were to expand it out, you'd get back 3x squared plus 13x plus 4. Now, if this is the first time you saw it because of distance learning, again, I just want to show a couple things here. First of all, when I divide this first chunk here by x plus 4, these x plus 4s cancel out, and I'm just left with 3x. Okay, so that's where I get that 3x from, that leftover. And then if I take 1 times x plus 4, this big chunk, and divide it by x plus 4, the x plus 4s cancel out, and I'm just left with positive 1. And then the other thing that I wanted to show was the FOIL here to check. So if I do multiply x plus 4 by 3x plus 1, using FOIL, I will get back what I started with. So x times 3x is 3x squared. X times 1 is 1x. 4 times 3x is positive 12x. And positive 4 times 1 is positive 4. The middle terms are like and add together. And you can see that you got back what you started with. Okay? So we know we're right here. So that's how decomposition works. And that's called a complex trinomial. And again, the difference between a simple trinomial and a complex trinomial is that a complex trinomial starts with a number other than 1. And whereas a simple trinomial, there's always a 1 in front. Okay, that you know is there, but you don't see. Okay, so again, our next one here, we're starting with a 6. We recognize it as a complex trinomial. And our first step is to multiply the first and the last term. So I don't necessarily know my 21 times table. So 6 times negative 21 is negative 126. So off to the side, I'm going to write negative 100 and, what was it, 26 x squared. And then I want to add to negative 5x. So I'm not going to maybe write out every single pair here. I'm going to wait till I start getting close. So negative 126 divided by 1 is negative 126. So I know negative 126 and positive 1 aren't going to work. They're not going to add up to negative 5. Negative 126 divided by 2, nope. Negative 126 divided by 3, nope. We're still 3 and negative 42 are not 5 apart. 126 divided by 4 doesn't go in evenly. I know 5 doesn't. 126 divided by 6. 6 and 21, no. 126 divided by 7. 7 and 18. We're getting closer, so I'm going to start writing them down. The bigger one has to be negative. So 7x and negative 18x, no. 126 divided by 8 doesn't go in evenly. 9 and 14, 9x and negative 14x. Okay, so you can see they multiply to give me negative 126x squared, and 9x plus negative 14x adds up to negative 5x. So again, the first step is the decomposition step. So I take 6x squared, and from a common factoring standpoint, what has more in common with 6x squared? 9x or negative 14x. I'm going to say 9x does because I know 3 goes into both 6 and 9. So plus 9x, then minus 14x, minus 21. So again, all I did there was break up negative 5x into positive 9x minus 14x. I kept the 6x squared the same and the negative 21 the same. So that's the first step of decomposition. Second step is to common factor the first two terms, in which case you want to find the biggest number that goes into 6 and 9. So that would be 3, because 6 doesn't go into 9. And then there's an x squared in one and an x in the other, so x. 6x squared divided by 3x is 2x. Positive 9x divided by 3x is positive 3. The sign that comes next goes next, so it's negative. There has to be a sign there, either a plus or a minus. And then what's in common with 14x and 21? Well, 14 doesn't go into 21, but 7 goes into both of them. So then I'm looking at this as negative 14x divided by negative 7 is positive 2x. And then negative 21 divided by negative 7 is positive 3. And remember I said if you do everything right, these are common binomials. They match, and they do. So that common binomial becomes the common factor, and the leftovers, 3x minus 7, form the other factor. Factoring by decomposition. All right, the next one, 6x squared minus 11xy minus 10y squared. So again, first step is to multiply the first term and the last term. And you're going to get negative 60x squared y squared. And then we want to add to negative 11xy. Okay, so multiplying two and negative, one has to be positive and one has to be negative. So I know it's not going to be 1 and 60, 2 and 30, 3 and 20, no, 4 and 15 sounds good. So the bigger one has to be negative. So 4xy and negative 11xy, or sorry, negative 15xy. So check, don't take it for granted. So 4 times negative 15 is negative 60. Xy times xy is x squared y squared. And 4xy plus negative 15xy does give you negative 11xy. So those are my two terms that I'm going to use to decompose. So what has more in common with 6x squared? 4xy or negative 15xy? I'm going to pick the 4xy because I know 2 goes into both 4 and 6. And then negative 15xy. And then minus 10y squared. So on the decomposition step, you're just decomposing the middle term into two terms that allow you to factor by grouping. So then you're looking at what's in common with just the first two terms alone. So 2 is the biggest number that goes evenly into 6 and 4. And then there's an x squared in this term and an x in this one, so x is common, but y is not common, it's only in the second term. So now I'm gonna mentally divide 6x squared divided by 2x is 3x. Positive 4xy divided by 2x is positive 2y. Sign that comes next goes next, so negative. What's in common with 15xy and 10y? 5. There's not an x in both of them, but there is a y. So then signs are really important here. Negative 15xy divided by negative 5y is positive 3x. Negative 10y squared divided by negative 5y. So negative 10 divided by negative 5 is positive 2. Y squared divided by y is y. And then again, you'll notice we get the common binomial. In this case, it's 3x plus 2y. and the leftovers form the other factor. All right. Next one, similar again. So complex trinomial, multiply the first term by the last term. 2x squared times negative 15y squared is negative 30x squared y squared. And so I'm multiplying to a negative, so I need one positive, one negative. Adding to a positive, bigger one has to be positive. It's not going to be 1 and 30. 2 and 15, I can try. So it's going to be negative 2xy and positive 15xy, but that adds up to 13xy, so they aren't the pair. Negative 3xy and positive 10xy, they do add up to 7xy, and they also multiply to negative 30x squared y squared. All right, so I'm going to use these to decompose. So 2x squared. What has more in common? I would say 2, I know 2 goes into 10, so plus 10xy minus 3xy minus 15y squared. So again, in my decomposition step, all I did was rewrite positive 7xy as positive 10xy minus 3xy. So then I factor by grouping. What's in common with just the first two is 2x, and then 2x squared divided by 2x is x. 10xy divided by 2x is 5y. Sign that comes next goes next. What's in common with 3xy and 15y squared? 3y. Remember, the negative is attached there. So negative 3xy divided by negative 3y is positive x, or positive 1x. And negative 15y squared divided by negative 3y is positive 5y. And if you do everything right, you get a common binomial. So one of the factors will always be that common binomial. And the other factor is formed by the leftovers, 2x minus 3y. So decomposition is definitely harder than a simple trinomial because it takes 3 steps to work it out. And it's a mixture of trinomial factoring and common factoring. And usually because you have to multiply the first term and the last term, the numbers you're dealing with are bigger. But if you just take your time, you can figure it out. Okay, another type of trinomial you could get is called a perfect square trinomial. It's if you don't recognize it, you can always factor it as a simple trinomial or a complex trinomial. But if you do recognize it, it's also one step. So for instance, you might see this as a simple trinomial and say to yourself, because there's a 1 there, invisible 1. I need 2 numbers that multiply to positive 16 and add to positive 8. And you could try 1 and 16. No, that doesn't add up to 8. 2 and 8 doesn't add up to 8. 4 and 4. So if you factored it as a simple trinomial, you'd get x plus 4 times x plus 4. But since both of the factors are exactly the same, you could write that as x plus 4 to the power of 2. Because there's 2 x plus 4s multiplying together. Okay, and that's what we call a perfect square trinomial. And you can go straight from here to here if you recognize it's a perfect square trinomial. So what makes something a perfect square trinomial? Well, the first term has to be a perfect square. Check. So x squared is a perfect square because x times x is x squared. The last term in the trinomial has to be a perfect square. So 16. And when I say perfect square, if you take the square root of 16 on your calculator, you get a whole number, okay, 4. So, and then the check is, if you multiply 2 by the square root of the first term. So the square root of x squared is x, and the square root of the last term is 4. You should get the middle term other than the sign. Okay? So there's the check. So here, if you thought this was a simple trinomial, you'd still get the right answer if you recognized, oh, 25 is a perfect square. So if I took the square root of 25, it's 5. To factor a perfect square trinomial, square root of the first term goes at the front of the bracket. Square root of the last term has to be positive, goes at the end. Squared on the outside, and then the sign from the middle goes in the middle. Okay? And then to check it, you would check that 2 times a times -5 gives you -10a. And it does. The middle term. This one, so 4x squared is a perfect square because if you take the square root, you get 2x. 9y squared is a perfect square because if you take the square root, you get 3y. The sign from the middle goes in the middle and it's squared. There's 2 of them. And then the check would be that 2 times 2x times -3y ends up giving you the middle term, -12xy. Same thing here. So square root of 4x squared is 2x. Square root of 25y squared is 5y, all squared. Sign from the middle term is positive. And then the check is that 2 times 2x times 5y should give you 20xy, which it does. So you know it's a perfect square trinomial. Again, if you don't catch that it's a perfect square trinomial, if you factored it as either a simple trinomial or a complex trinomial, in this case where the number in front's a 4, you'd still get your 2 identical factors, and it wouldn't matter for your final answer. The only thing, it saves you time especially if it's one of these. If you see it as a complex trinomial, it's going to take you 3 steps, but if you realize it happens to be a perfect square trinomial, it only takes you 1 step. Okay, a difference of squares, also 1 step. So what makes something a difference of squares? So if you look at, just before you write anything down, if you look at x squared minus 25, why would we call that a difference of squares? So x squared is a perfect square. And a perfect square is just something that you can take the square root of. Square root of x squared is x. 25 is also a perfect square. Square root of 25 is 5 exactly. We call it a difference of squares because it's 1 perfect square and then subtracting another perfect square. Okay? And they have a special pattern they factored to give you. So the way you factor a difference of squares is you know there's going to be 2 binomials multiplying together with an x at the start of each, and because that's the square root of x squared, and then the square root of 25 is 5 at the end of each, and they have to have opposite signs in the middle. Why do they have to have opposite signs in the middle? And the reason is because when you expand using FOIL, x times x is x squared, x times -5 is -5x, positive 5 times x is positive 5x, and positive 5 times -5 is -25. And what ends up happening is if you have opposite signs in the middle, then these middle terms add up to 0. So negative 5x plus 5x is 0, so you're just left with x squared minus 25. Okay? So that's how come you need a positive in one of the bracket and a negative in the other when you factor a difference of squares. And then everything else is the same. They start with the same, they end with the same. The signs in the middle are opposite so that the middle terms cancel out and you're just left with a difference of squares. So again, two perfect squares separated by a minus sign is a difference of squares. So if you were thinking, what's the square root of 4m squared? What multiplied by itself gives you 4m squared? The answer is 2m. So there's a 2m at the start of each bracket. And then you're also thinking square root of 9 is 3. 3 at the end of each bracket. And then they have to have opposite signs in the middle, plus in one, minus in the other. Doesn't matter which one comes first, which one comes second, the plus or the minus. Same thing with C, difference of squares. So you're thinking square root of 9x squared. What multiplies by itself to give me 9x squared? 3x, so there's a 3x at the start of each. 1 often confuses people, but the square root of 1 is just 1. Try it on your calculator if you're not convinced. So the square root of 1 is 1, and that's because 1 times 1 is 1. So there's a 1 at the end of each bracket, and then they have opposite signs, a minus in one, a plus in the other. So 3x minus 1 times 3x plus 1. So I always think of differences of squares as a pattern type of factoring. Okay, so when I was in high school, we were taught to factor a difference of squares. It followed this pattern. A plus B times A minus B. You might want to write that onto your factoring flow chart. Under difference of squares, it follows the pattern A squared minus B squared equals A plus B times A minus B. It always follows that pattern. Okay, x to the fourth minus 9. A little star beside this one. It's a little tricky, but still it's a difference of squares. So if you think about what's the square root of x to the fourth, that means what multiplies by itself to give you x to the fourth, and the answer is x squared. Because if you think about it, x squared times x squared using the exponent laws is x to the fourth. So there's an x squared at the front of each. And then what's the square root of 9? It's 3. So there's a 3 at the end of each, plus in one, minus in the other. Okay? So this doesn't always have to be x squared. It can be x to the fourth, x to something even. And you can take the square root of it. X squared minus y squared. Again, this is an important one. A lot of people don't see it as a difference of squares, I think, because there's a y there instead of a number. But the square root of x squared is x. And the square root of y squared is y. And then you just need opposite signs. (9a squared minus 25b squared). So we want the square root of 9a squared is 3a, because 3a times 3a is 9a squared. Square root of 25b squared is 5b, because 5b times 5b is 25b squared. And then you need a plus in one and a minus in the other. So those are differences of squares. Okay, so now we're on to kind of what factoring would have ended up like for you in grade 10. So factor fully, we've gone through like all the different times, but all the different kinds that you learned in grade 10, but now you kind of culminated last year in factor fully, always check for common factors first, use the flow chart, identify the types of factoring involved. Okay, so here we go. Just putting it all together now. This is important. So you always have your flow chart out, and the flow chart always tells you to check for common factors first. So in the first question here, A, you check and see if there's any common factor, and the answer is yes, 2 goes into 18. So if I have to say the types of factoring involved, I'm going to say common, and then I'll do the common factor part. So if I common factor 2x squared divided by 2 is x squared. Negative 18 divided by 2 is negative 9. All right, so I've done the first part of the flow chart. Always check for common factors first. Now it says to count the number of terms in the brackets. So count them. There's 2 in the brackets. So if there's 2, then my flow chart says to go here. Is it a difference of squares? So that's my only choice. Either it's a difference of squares or it can't be factored. So is x squared minus 9 a difference of squares? Yes, it is. So I'm going to add that to my list. There's also a difference of squares. So I leave the 2 out front, and then I'm going to factor this difference of squares. Square root of x squared is x. Square root of 9 is 3. Plus in one, minus in the other. Okay, and then if I follow my flow chart, it then goes all the way down to this bottom box where it says if any of the factors contain a term of degree 2, which basically means like an x squared term. So if any of the factors contain an x squared term still, check to see if there's any more differences of squares. Okay, none of my factors, so 2 is a factor, x plus 3 is a factor, and x minus 3 is a factor. None of them contain x squared, so I'm done factoring. So I had 2 types, and it's fully factored. The next one. Okay, so follow my factoring flow chart. Check for common factors first. Is there something in common with all 4 terms? Other than 1, no, and 1's not considered a common factor. Okay. So now I count the number of terms. There's 4 terms. So that means I have to factor by grouping. Okay. So we've kind of done that within decomposition, but we haven't formally done it maybe since grade 10. So factoring by grouping is similar to what happens in decomposition where you just factor the first 2 terms and the last 2 terms and then hope for a common binomial. So if you're just looking at the first 2 terms, what's in common with them? 1, and then also there's an x in both of them, and you choose the x with the smaller exponent. So x squared is in common with both of the first 2 terms. So x cubed divided by x squared is x. 5x, or positive 5x squared divided by x squared is just positive 5. Sign that comes next goes next, so minus. What's in common with 9x and 45? Well, 9 goes into 45, so negative 9 is in common. Remember the sign is attached, so I'm thinking negative 9x divided by negative 9 is positive x. Negative 45 divided by negative 9 is positive 5. And then look what happens here. I get this common binomial. So if I look at this as one chunk and this is another, x plus 5 is in common. And then the leftovers, x squared minus 9, form the other factor. Now, before we follow the flow chart a bit more, what did we use here when we had 4 terms? We used grouping. All right, so looking at my flow chart, I checked for a common factor, there wasn't any, counted the term, there was 4, so I factored by grouping. But now it sends me down to the bottom of the chart where it says if any of the factors contain a term of degree 2, which means like an x squared, check to see if there's a difference of squares. So the first factor, x plus 5, doesn't have x squared in it, but the second one does, x squared minus 9. So you have to ask yourself, is x squared minus 9 a difference of squares or not? And it is. So it can be factored further. The x plus 5 just stays the same, but x squared minus 9 can be factored to give me x plus 3 times x minus 3. So there's also a difference of squares. I just used DOS for a short form there rather than writing out difference of squares. DOS, difference of squares. Now it's fully factored. None of the factors have a degree 2. Done. All right, we're on to C. So always check for common factors first. So I've got 3 terms. 5 goes into 60, so 5 for sure. There's an x in all of them. Smallest exponent is x. So I've got common for sure here. So I'm going to divide each term by 5x. So 5x cubed divided by 5x is x squared. Positive 5x squared divided by 5x is positive 1x, or just positive x. And negative 60x divided by 5x is negative 12. So there's my first stage, common factoring. Then I go to my flow chart. It says to count the number of terms in the brackets. So there's 3 terms in the brackets. So 3 terms, I have 3 choices. It could be a simple trinomial in the brackets, which means it's just 1 step. It could be a complex trinomial in the brackets, which means it would be 3 steps, or a perfect square trinomial, which would also be 1 step. So in my case, there's a 1 in front of the x squared in the bracket, so it's a simple trinomial. Which means, so I keep the 5x there, but in order to factor this into 2 binomials, I need to find the 2 numbers that multiply to negative 12 and add to positive 1, because there's really a positive 1 in front of the x. So to add to a positive but multiply to a negative, it'll be a 1 positive, 1 negative, bigger number, positive. So I could use bigger number positive. So negative 1 and 12 does not add up to positive 1. Negative 2 and 6 does not add up to positive 1. Negative 3 and 4 does. And then it sends you down to the very bottom. If any factor contains an x squared, none of them do, so I'm done. 2 types of factoring, common and simple. Okay, D, first step is to check for common factors. So I know 4 goes into 100, and there's an m in both, so smaller exponent is m. So I know common is going to be one of my types. 4m cubed divided by 4m is m squared, minus 100m divided by 4m is 25. And then, okay, so we've done our common factoring. Count the terms inside the brackets. There's 2 terms. If there's 2 terms in the brackets, either it's a difference of squares or you're done. You can't factor any further. So you have to ask yourself, is m squared minus 25 a difference of squares? Yes, it is. So it can be factored to give m plus 5 times m minus 5. And then none of the terms have an m squared in them anymore. So we're done. E. So I always check for common factors first. And my rule is that if there's a leading negative, you always make that common. So in this case, -1 is the only common factor. Nothing else is common. But if I divide each term by -1, I'm going to just flip all the signs because -1x squared divided by -1 is x squared. -4x divided by -1 is positive 4x. And positive 21 divided by -1 is -21. So then count the term inside the brackets. There's 3. Is what's inside the brackets a simple trinomial? Yes, it is. So I can leave the -1 out front, or I can just leave it as a negative sign, okay, which is probably what the textbooks would do. And then I want to break out this into 2 binomials. And I need to do that by finding the numbers that multiply to -21 and add to +4. So the bigger one's going to have to be positive. So I could have -1 and 21 does not add up to +4. 2 doesn't go in, 3 does. So -3 and +7, those are my numbers. So x minus 3, x plus 7. And then neither one of my factors contain an x squared term, so I'm done. 81 minus x to the 4th. So is there a common factor? No. Count the terms. There's 2. So either it's a difference of squares or it can't be factored. So if I'm checking if it's a difference of squares, I see it's negative. It's 2 terms subtracting, so that's good news, but I want to see, is 81 a perfect square? So I could check that on my calculator. It is. So that means that I can do 9 at the beginning of each bracket. Square root of x to the 4th is x squared. So an x squared at the end of each bracket, a plus in one and a minus in the other. Now, it does matter that the 9s come first and the x squareds come second. Okay, so you can't just switch them around because you want to, or because that looks more normal to you. Okay, it does matter the order, because if you were going to expand using FOIL, you can see the firsts give you the positive 81 and the lasts give you the negative x to the 4th. And if you did it the other way around, your signs would be opposite. But we're not done. So we go down to the bottom box here on our flow chart, and it says if any of the factors contain an x squared term, check to see if it's a difference of squares. So our first factor, it has an x squared term, but it's not a difference of squares because the squares are adding to each other, 9 plus x squared. So that one can't be factored, it's just going to stay the same. But that's not the same in the second one here, 9 minus x squared. It is a difference of squares because the square root of 9 is 3. So I can break this one down into 3 plus x times 3 minus x. Okay? X squared is a perfect square, so is 9. It's a difference of squares. And now we're done because neither of these 2 factors have an x squared term. This one does, but it doesn't factor because it's not a difference of squares. It's a sum, or adding 2 squares together. And so what were our types here? Well, we had one difference of squares, and then we had another difference of squares. So there was 2 difference of squares to fully factor that. All right, G. First step again is always check for common factors first. So I know 3 goes into 60, so 3 is going to be part of my common factor. There's not an A in all 3 terms, nor is there a B, so 3 is my common factor. And then in the brackets, I'm going to get A squared minus AB minus 20b squared. Okay, so there's my common factoring done. Now it tells me to count the number of terms in the brackets. There's 3. And inside the brackets, it's a simple trinomial because there's just a 1 in front of the a squared there, which means For a simple trinomial, it's just one more step now. Break this down. So there'll be an A at the start of each bracket, a B at the end of each bracket, and then two numbers that multiply to negative 20 and add to negative 1 in this case. So they're going to have to be opposite signs and the bigger number being negative. So it could be 1 and negative 20, but that adds up to negative 19. 2 and negative 10 adds up to negative 8. 3 doesn't go in. 4 and negative 5. So it's going to be A plus 4B times A minus 5B. So we used common factor and simple trinomial. None of my factors have a squared in them, so I'm done. For H, check for common factors first. Always with a leading negative. Negative is going to be part of your common factor. 5 goes into 20, so 5 is part of my common factor. There's not an x in both of them, but there is a y in both of them. So I'm going to divide each term by negative 5y to common factor it. So there's one of my types. So negative 5x squared y divided by negative 5y is x squared. Positive 20y divided by negative 5y is negative 4. So then it says to count the number of terms in the brackets. There's 2. So we are asking ourselves, is it a difference of squares? Is x squared minus 4 a difference of squares? Yes, it is. So we can factor further. X plus 2 times x minus 2. Or x minus 2 times x plus 2. Done. All right, I am leading negative, so we're definitely going to have a common factor. And that's all, negative 1's all that factors there. So that's going to give me positive x squared plus 2x minus 15. And then count the terms in the brackets. There's 3. It's a simple trinomial. So then I would need two numbers that multiply to negative 15 and add to positive 2. So the bigger one's going to have to be positive. Negative 1 and 15. And negative 3 and 5 it would be. So I leave my negative out front, probably just as a negative sign. And then x minus 3 times x plus 5. J, x plus 4 squared minus 25. There's a couple ways to do this one. I'll show you both ways to do it. The first way to do it is to first check for common factors. There isn't any. Count the number of terms. And if you see this as one term, one big chunk, and that is one big chunk, then really you've got two terms. So then you're asking yourself, is it a difference of squares? It is, but it's harder to see because you have to be able to see that the square root of x plus 4 all squared. Well, you know that square root undoes squared is just x plus 4. And the square root of 25 is 5. So it is a difference of squares, even though it's a more complicated looking difference of squares. So the square root of x plus 4 all squared is x plus 4, which means an x plus 4 goes at the start of each bracket. And the square root of 25 is 5. A 5 goes at the end of each bracket. And then there's going to be a plus in one of them and a minus in the other. But it turns out that there's like terms within the brackets. Positive 4 plus 5 is positive 9. And positive 4 minus 1 is negative 1. So that's how you factor it using a difference of squares. The other way that you could factor it would be to first expand it all out. Using FOIL and then classify it. So you're not even factoring at this point, you're just expanding. And if you miss that it was a difference of squares, this would be your fallback plan. So those were like, so I got 8x, 16 minus 25. I believe that's negative 9, yeah. So you've done no factoring here, but you've expanded this because you at first didn't realize it was a difference of squares. From this way, looking at it just looked complicated, so you decided to expand and simplify. But now that you've arrived at this step, you would still use your factoring flow chart now that you've simplified it. Is there a common factor? No. Count the terms. There's 3. Is it a simple trinomial? Yes. So now at this point, it would break into the 2 factors, and you'd be looking for 2 numbers that multiply to negative 9 and add to positive 8. So bigger one would have to be negative. Bigger one would have to be positive. You're adding to a positive. So they would be negative 1 and positive 9. Yes. And you can see that that's what we got when we did it using a difference of squares that we recognized. So good thing is, if I didn't recognize that was a difference of squares, I could still get the answer correct. Okay. All right. K and L are kind of like new for grade 11. So grade 10s, you haven't seen this type of grouping before. Okay. So first thing you do is check and see if there's a common factor in all 4 of the terms, and there isn't. And then it says factor by grouping. And in grade 10, we always did 2-2 grouping. We did it in complex trinomials. We did it earlier in this question right here, 2-2 grouping, but there's also 3-1 grouping. So we'll add this. There could also be what I call 3-1 grouping, which is kind of cool. And I always relate it when I'm teaching you guys to Sesame Street, because that's what I watched when I was little. But in Sesame Street, there'd be like, the TV would be divided into 4 squares. And in 3 of the squares, there'd be a kid bouncing a ball. Okay, so all these 3 kids would be bouncing a ball. And then it would always be one of these kids is doing their own thing. And it would be someone like under an umbrella or roller skating, like just something different than the other 3. Okay. And that's what 3-1 grouping is kind of like. There's always like one term that doesn't seem to go with the other 3. And in this case, it's the negative 16y squared. So these 3 terms go together. I put them in a box. If you're recently from grade 10, you'll know why. Okay. And the other one's kind of doing its own thing, so it's staying out for now. Now, what ends up being in the box is always going to be a perfect square trinomial. And if you remember perfect square trinomials, they're one step, but they also factor to give me something like this. 1 bracket with a squared on the outside. Okay. And remember, they always start with a perfect square. So in our case, this one starts with the perfect square of x squared. So the square root of x squared is x. The sign from the middle is plus, and the square root of 25 is 5, and then it's all squared. Minus 16y squared. Okay, and then what happens is it turns into this question almost exactly the same. So it starts off as a grouping question, but because we used 3-1 grouping, now it's a difference of squares. Okay, so x plus the square root of x plus 5 squared is x plus 5, so there'll be an x plus 5 at the start of each bracket. The square root of 16y squared is 4y. So there'll be a 4y at the end of each bracket, and then a plus in one and a minus in the other. And you would look and see if there's any like terms, but in this case, there's no like terms. There's an X ending, a plain number, and a Y ending. So that's as low as you can go, and that's 3-1 grouping. And L is also 3-1 grouping, where m squared, 8m, and 16 make a perfect square trinomial. And then negative 25n squared is kind of doing its own thing with the n. So this is our 3-1 grouping again, where this factors to give me square root of m squared is m, sign from the middle is negative, square root of 16 is 4 squared, it's a perfect square trinomial, minus 25n squared. And then it turns into a difference of squares. So something squared minus something squared. So really there's just two terms here, one kind of big term and then a regular size term. Subtracting, and they're both perfect squares. The square root of m minus 4 squared is m minus 4, goes at the front of each bracket. The square root of 25n squared is 5n, goes at the end of each bracket. Plus in one, minus in the other. And again, none of them are like terms, so you'd be done the question. All right, we're getting there, guys. Last question's important for the next lesson later today. True or false, does 5 minus x equal negative x minus 5? So let's do like a left side, right side. So on the left side, we have 5 minus x. On the right side, we have negative x minus 5. If we distribute the negative 1 on the right side, we get negative 1x or negative x. And negative 1 times negative 5 is positive 5. And then if we just rewrite them in a different order, so we write the positive 5 first, you don't need to show the positive out front, and then negative x second, you do get the same thing on both sides, okay? So this proves that this is true. And then a parallel question for that is b minus a always equal to negative a minus b. We can show that again. B minus a and negative a minus b. That's like a negative 1 there that you can distribute. Negative 1a is just negative a. Negative 1 times negative b is plus b. And if you just reorder them, positive b minus a. You get the same thing on both sides. So this is what we call an identity. All right, so, and we'll see where they come in later. All right, so I'm going to exit out of this and come back to you guys. Talk to you for a minute, stop recording, etc. Okay, so I'm going to stop sharing and I'm going to stop recording.